Okay, good evening, everybody. I see that it's now 7 o'clock, so we will start with Usomi webinar. My name is Merel Huisman, and I'm a resident in radiology who's interested in AI from the Netherlands, Amersfoort to be precise. And tonight I am moderating together with Erik Hansgaard, the Usomi president. First, we would like to thank our sponsor, Bracco, for sponsoring our monthly webinar series. And next, I would like to introduce Dr. Karim Lekadir, our speaker of today. Dr. Lekadir is currently Director of the Artificial Intelligence in Medicine Lab at the University of Barcelona. He holds a PhD from the Imperial College London of the UK and was previously a visiting scholar at Stanford University. His current research focuses on machine learning approaches for the analysis of large-scale biomedical data, imaging as well as non-imaging data. Currently, he's also the coordinator of the You Can Share Horizon 2020 project. This project is developing an international centralized big data platform for personalized medicine research in cardiovascular diseases. Also, he has central roles in several other H2020 projects, namely Early Cause and Long Eye Tools. We are very happy to have him as an expert speaker on the topic of today, data sharing platforms to facilitate methodologically sound and centralized research. I think this is a very timely topic and everybody seems to be talking about this topic at the moment. For the attendees, if you have any questions during the webinar, you can type your questions in the Q&A box on the bottom, and we will either be able to answer them during the lecture or after, depending on the questions. So yeah, that would be it. So Dr. Lekadir, the digital floor is yours.
Thank you, Merel. Thank you, everyone. It's really a pleasure to be invited to give a talk at the European Society of Medical Imaging Informatics. It's also a pleasure to present initial results from European project in which collaborate multiple partners, universities, clinical partners, industries. And the subject of this talk would be data sharing and analytics platform for medical imaging in the age of big data. So we all heard of big data, of course. We know why is it important, why is it useful. We have all sorts of applications in mind, in particular in the biomedical domain. Something we are struggling with a little bit is to access big data in the biomedical domain, particularly in medical imaging. So in other domains, so let's say image recognition of natural scenes, there are already very big data sets. So the famous ImageNet database, it has 14 million images, 20,000 categories, which is quite impressive. And I would say it's relatively easy to begin building such a database. You need a smartphone and you can go outside and take photos. In the medical imaging domain, for example, it's much more complex. So let me give you a concrete example of the complexity. So this is a concrete use case. This was a discussion we had in Barcelona with the Hospital Clinic Barcelona, and they asked us whether it would be possible to build an AI solution that would identify small HCC lesions in cirrhotic liver. So these are lesions that are less than 2 centimeters. And of course, the first step would be to look at for data to train the models. So we went to the best place for that, which is the Cancer Imaging Archive, which is well established, has about 50,000 cases, and we made a search, liver plus MRI. And we only found 41 cases. And we couldn't search per lesion, so we didn't know whether these were lesions that were less than 2 centimeters. But clearly, we didn't have enough data sets to undertake this task. Now, interestingly, if we look at the details of the Cancer Imaging Archive, they have, I would say, a lot of data on the breast, chest, head, neck, brain, colon, lung. But then for cancers like liver, pancreas, kidney, prostate, we have many less. And yet they are important cancers that need to be addressed. So given the fact that we couldn't find the data in this case, we turned our attention to a discussion with our clinical partners in Barcelona, namely Hospital Clínic Barcelona. Now, we are lucky to collaborate with them because they are also a world authority on liver cancer. In fact, they established the famous Barcelona Clinic Liver Cancer Staging System. So we thought if somebody has data, it had to be them. So we talked to them, and indeed they had some data sets, but it was still not enough to build an AI solution that would generalize 400 cases. So we thought, okay, we need to contact other institutions. So we started with Hospital Clínic Barcelona, and then we went around in Europe. We sent emails trying to get at least a couple of thousand cases. Now, this was a tedious task. In fact, to get an answer from this, we had to contact many more. And what we realized is that these clinical centers that treat everyday patients, they don't know actually what they have exactly. It's not easy even for them to get access to information. So it is a difficult task to know whether there is the data set to address a specific task of artificial intelligence. Let me give you another example, which would be more related to the talk today and the European project that we'll present. This is related to cardiac imaging. So another task we looked into in Barcelona is whether it's possible to build a neural network which segment cardiac images with high accuracy, but across different scanners, across different centers, and across different diseases. And the reason we looked into this is because we realized that if we build a model from a given database, then it doesn't necessarily generalize well to other databases. So to be able to work on this use case, we contacted several hospitals and clinical centers, which are collaborator of ours. And the same difficulty was encountered. That is, it was difficult for them as well to identify which were the cases they came from specific scanners, specific diseases. There was no tool to actually search that database in an efficient manner. And this motivates the work we are doing in this European project that is called You Can Share. It is funded by the European Commission. And the goal is to build a centralized data platform that will facilitate access to information, that will facilitate access to the data and access to analysis tools. And we want this as a one-stop shop or a single entry data portal. We would prefer that the users have an experience in the same place instead of having to use different tools, different means of communication, different means of looking for information. So these are the objectives of the You Can Share project. To build a platform that will facilitate data searches. So searches per modality, for example, contrast MRI, search per disease, for example, data sets with diabetes cases, searches per cardiovascular structure, and even per access condition. For example, would an SME or a company have the right to access this data? We want to facilitate trusted and responsible data sharing. We want the data provider to have trust in these sort of platforms so they can share more data in the future. We want them to facilitate the data access. At the moment, data access procedures are tedious, are lengthy, they take months sometimes. So this is also an opportunity to facilitate the transactions and the communication between the researchers and the data providers. And finally, we want to facilitate the multi-center studies because they are very useful, as I showed with these two examples, to obtain large data sets and heterogeneous data sets. So to do this, we'll follow a guideline that has been established over the years. It is called the FAIR Guiding Principles for Data Management. And each letter of the FAIR word means something. F stands for findable, A is accessible, I is interoperable, and R is reusable. So I'm going to go through them in this presentation, and I will explain how they may apply to medical imaging. So this is really early stages. There are a lot of projects around on this, and what I'm going to show is one example. So a few acknowledgements before I start presenting the platform itself. I'd like to acknowledge that first, this is an effort of multiple partners across Europe, several universities, hospital companies, and in particular, a number of data infrastructures that exist across Europe. I think we are lucky in Europe to have these world-class data infrastructures like EBMRI, the European Genome Archive, ELSI, and also Eurobioimaging, which became an ERIC very recently and which is playing a very important role in this field. I would like also to acknowledge all the different partners across Europe and also in Canada in context of this project, because it's a European-Canada collaboration who allowed us to develop this project based on their data, and these are 35 cohorts. So this is very important to acknowledge. And finally, this is just, as I said, only one project in the field of fair data management. There are several others that are funded by the European Commission with different focuses. So for example, UCAN is focused on cancer genomics, Recorded on infectious diseases, have interesting cohorts from South America. CINECA has cohorts from Africa. Life Cycle focuses on both cohorts. Longitudes focuses on exposome data such as air pollution. So let's go now through the different components of the Fair Data Management Plan and how they apply in the You Can Share project. So first, findability. Findability means we need a data catalog that can be searched, which is a database of metadata about the cohorts. So to have detailed information about the cohort, including the variables that are available, we need fields that are searchable, so we can search for the information. We need the model of the metadata that is structured, domain specific. We need ideally one for imaging, different one for genomics. Interestingly, it is possible to build a data catalog without the raw data, which is important because that means even if it is not possible to openly share the data, it is still possible to add the cohort into the data catalog into the platform so it can be found, and so collaboration then can be initiated. So let me give you an example of a simple data catalog. So the one of the European Genome Archive. So has a very simple search engine. For example, if I type cardiovascular, it tells me that there are 94 data sets. And then I can click on one, and then it tells me who to contact to establish the collaboration and some information about the cohort. However, it's still not detailed enough. We don't know which variables there are there, which phenotypes. We cannot search per disease or per data type or per variable. And we still need to use emails to contact the data provider. So I'm going to show the first version of the data catalog of You Can Share, which was built by looking at 42 data sets. We made an inventory of all variables. We selected most relevant variables for the search engine because we cannot have hundreds and hundreds of search variables. We need to decide which are more relevant to perform a search. And we built the catalog using an existing technology that comes from our collaborators in Canada, which is Marstrom Research. I really recommend that you have a look at their website. They are a world authority in data management. And they have a tool called Mika, which allows to build these data catalogs from search variables. And the actual database itself is now centrally stored in Barcelona at the Spanish node of ELSI. So this is how the platform looks like. This is the first version. We are 18 months through the project, and we still have 2.5 years until its end. Therefore, we still have time to develop it and improve it and optimize it and test it. But we obtained a first version that I can show you. So it allows to access the data catalog through here. And this is how the data catalog looks like. It's basically first gives all the cohorts that are available. So in this case, 42. But then it is possible to perform a search. Now, what's interesting is that now the search is much more advanced and much more detailed. So for example, it is possible to choose as a search field tobacco or smoking. So individuals who smoke. It is possible also to choose a disease, for example, diabetes. And then we obtain a search result of 24 datasets that correspond to our search criteria, as they are listed here. Now, we could add other search variables. It's a very detailed engine, very powerful, that has different categories of search metadata fields, including on health and community care services utilization, but also on laboratory measures that are listed at the bottom. Now, interestingly, if you can see at the bottom, there is genomics, there's microbiology, biochemistry, but there's no imaging yet, because this version of the tool was developed in various projects in the past that did not have imaging. So we are the first to actually extend this tool to include imaging. And to do this, we followed the following steps. First, we made a detailed inventory of all the data, and we looked at those that have imaging. And then we looked within this cohort, the content of the cohort, to see which search variables we could extract. So we realized that there are different organs within these cohorts. So, of course, cardiovascular, because most of the cohorts focused on the heart, but not only the brain, the carotid, liver, etc. Then we realized that there is a large variety of imaging sequences. So this is also important to be able to search per image sequence, because for certain clinical questions, there is a need for a given imaging protocol. For example, 3T FLAIR, for example, or 3T CINE, etc. We also realized that there are large variability of vendor equipment, which could be also used as the search criteria, and then biomarkers. So again, here it will be possible for the user to search a very specific biomarker that the clinical question demands. So now we've done this work, what we need to do now is approve it through consensus. We have different experts that we are talking to make sure that the cardiac imaging experts first agree that this should be the search variables that should be incorporated, and then its implementation within the tool will follow. So this is the first part of the platforms. Now I'm going to move to the second part, which is the A of FAIR, which is accessibility. So now we found certain cohorts that correspond to certain criteria. How do we access them? So traditionally, have to send emails or apply, go to each of the websites one by one and use different access request procedures. Now, what we want to do here is something different. We want to centralize this process and make it more efficient, both for the user, for the researcher, but also for the data provider. Now, to do this, you can share, one can navigate through the cohort and select the variables that they are interested in for their clinical question. So typically not all the variables are necessary, and rarely does the researcher request all the variables. So once you select the variables that you're interested in, you can then add them to the cart, like an Amazon cart. It's the same. You add them to the cart, and then later on, you go to data access request and you create a request. So you put the contact information about the research project, maybe you upload a CV, and then you sign, you validate, and then it goes to all the data access committee. This is how it works. So the user is here, sends the access request, the portal sends or transfers the access request to the different data access committees, who then give, for example, the authorization. Once the authorization is given, they send the data through different protocols securely. Then they are in the cloud infrastructure of you can share. And then the user can perform some data analytics. Alternatively, if the raw data cannot be moved from the local cohorts, we send the tools instead, using a federated approach. Now, this is still rather manual, or has some degree of interaction. We would like to go even further than that. We are wondering if it is possible to do this automatically. So for that, I would like to mention the My Health, My Data European project that finished recently, which built a blockchain-based system to automatize this process. And the idea is the data provider has a profile on the blockchain, a computer-readable profile with all the information, in particular data use conditions. For example, this data cannot be used by a company. And then the users have also their own profile. For example, we are a company. And then automatically, there is a matching algorithm that checks whether the data access request is compatible with the data access condition. And because it uses a blockchain, it's decentralized, so it's difficult to hack. This is something we will pilot test in this project. In addition to these aspects, to improve accessibility, there are legal and ethical aspects that need to be addressed that are very important. It's worth mentioning, even though it's not the topic of this talk. So legal compliance, obviously. So it's important to identify the differences between regulations and policies across Europe and even beyond. It's also important to use technical standards, for example, for anonymization of the data. And then more generally, within this project and other projects, there are actions to increase open science and to promote responsible data sharing and increase cooperation. So these aspects are also important to increase the accessibility of data. Now I'm going to move to the third part, which is the interoperability, which is very important indeed. And there are different reasons that make the data not interoperable. One obvious one is that the data is acquired in different places using different formats, and therefore they cannot be used directly, combined directly in data analysis tasks. So for example, there are different ways to store a variable as simple as age. One way is to have date of birth and date of data collection. Another way is to have age as data collection. But it's important to have a common variable, so statistical method could be applied. And in You Can Share, we're going to use, again, a tool from Maelstrom Research called Opal, which is basically a database of rules, of harmonization rules. So the user can search in the database to find a harmonization rule and then applies it. Or if the harmonization doesn't exist, there is a scripting API that can be used to actually create a new rule and then store it in the database. So that's one source of issues that reduce interoperability. Another one is the fact that the measurements in two centers can be made using different machines, for example, in the case of imaging, different scanners, different operators, etc. So we need a method to address this issue as well. For example, if we want to do segmentation, as I discussed previously, the fact that the imaging data acquired different using scanners can be problematic. And this is why we decided to organize a challenge as part of the conference MICAI 2020. The challenge is called Multi-Center, Multi-Vendor, and Multi-Disease Cardiac Image Segmentation. It's organized by one of our PhD students, Victor Campeo. And the idea is to invite researchers around the world to propose new solutions that are that generalize better to different types of data, different scanners, different centers, to increase interoperability. But the problem doesn't appear only at the segmentation stage, it also appears at the quantification stage. So this is a nice study that was performed in London, where 110 subjects were scanned twice. So this is a scan rescan study. And then 3 types of methods were used to quantify indices such as volumes and ejection fraction in cardiac MRI. And they found that there were indeed problems of reproducibility. In many cases, there was a coefficient of variance over 5% or even over 10%. So we took the same data set in collaboration with Queen Mary University of London, and we performed the same data, but we went a step further and we performed the radiomics study. So radiomics, to present it briefly, is an approach through which a larger pool of features are calculated from the regions of interest. So these features can be shape-based, size-based, intensity-based, texture-based, obtaining a large number of features that could be used for deeper image phenotyping. In the cardiovascular imaging case, instead of using a few features such as volumes and ejection fraction, we have a larger set of intensity and texture features. We performed this study, and what we found is that for shape radiomics of the LV myocardium, 1/3 of them were considered moderate to poor feature in terms of reproducibility. Another 1/3 were considered good, and the last 1/3 as excellent, which means intra-class correlation coefficient over 0.9. Now, interestingly, for the RV, the number of features with excellent reproducibility, it drops to 6%, because the RV is more complex to segment. For intensity, that's the opposite. We have a much larger number of features with excellent reproducibility, which show that there is potential in using these more advanced textures instead of using only shape-based indices in cardiac imaging. These are some examples. As you can see, these are normalized figures, Blood-Altman plots. You can see the difference between a feature that has excellent repeatability, for example, the volume, versus flatness that has a moderate repeatability. In entropy, excellent repeatability, versus screwness with good repeatability. And then a texture descriptor, inverse difference moment, excellent repeatability, versus cluster shapes that has poor repeatability. So this allows us to come up with a solution to enable increased interoperability, to select the radiomics that are robust and only use those as standardized features to perform a cardiac image quantification. That's one solution. Another solution would be to perform normalization and image synthesis, and a lot of people are working on this using GANs, for example. So this was interoperability. I'm going to move to the last part of the talk, which is the reusability, which is the R of the FAIR guiding principle. And here, what we decided to include in the platform is a flexible and advanced computational environment for researchers to, after they have access to data, to build computational workflows to analyze the data. So here The first version includes image quality control, cardiac image segmentation, radiomics, machine learning, other things like multiomics, etc. So to do this, there are two ways one can process the data. One is to add a local data set, for example, directly through drag and drop. Another approach is to use the data that we found in the catalog and for which we obtained access. So they are here and we can add them to the user workspace. Once this is done, we have all the data here that we can select to perform a number of quantifications. So we could choose the file type, the data type, and also the study. So for example, we could choose images. So here the number of cardiac images. We select them. And then we can perform image analysis, in this case, cardiac image segmentation. So we choose cardiac image segmentation. We give a name to this run. And then we choose the images. And then we choose the technique to segment these images. For example, the UNet trained with ACDC data. These are data that is from a past MICAI challenge called ACDC. And then we execute the run. Now it is pending. It's running in the background and the user can continue with the further analysis. Once it is done, the results are added to the user workspace. So here they are, now the results. But now we can also perform further analysis by selecting the masks that were just computed, but also information about clinical outcomes. So here it's a data set of patients with myocardial infarction and subject without myocardial infarction. So we select them, and then we have now a new tool that we can use, which is the radiomics. It is selected. We give it a name. This shows all the data, the mask, the images, and the outcomes. And the run is computed. And then the results are saved in a CSV file. You can download it and have a look at it. These are the results. And then we can also do machine learning here. We want to build a model that will predict the myocardial infarction. This is a simple example. Same thing, we give it a name, we add it to the computational environment. We select a method, for example, random forest, and then we let it compute. And we obtain the result as a PDF in this case. So we can access it and open it. And here we get information about the data, the computational workflow. Here we are given the results, which are the most predictive radiomics that were selected by the machine learning model, and the results of the cross-validation. Now, what's interesting here is that everything is done in the same place. The user doesn't know whether the data is stored locally or whether it is stored on the cloud, whether the tools are located in one place or another. All the tools are in the same place, and this facilitates access to information, requesting the data, and then using them later on. And also something we're trying to do here is build a platform that will have a collection of analysis tools, which means non-experts could use them. So this is important in the context of democratization of AI, as they said. So it will be possible for somebody to use these tools, as I just showed, if there is limited expertise, the tools to perform a grid optimization of the parameters automatically. And then somebody who has an expert in imaging but has limited expertise on genomics will also find similar tools that could be used, for example, to perform imaging genomic studies. So this is near the end of my presentation. I have 3 take-home messages I would like to give you. So first of all, that this is really an important topic at the moment, because there is a belief that this will have a lot of benefits. There was a report, the European Commission, that the cost of not having fair data is 10.2 billion euros. This is because there is now, we know that there is a lot of data across Europe in many places, and they are frozen. They are not used, or they are used in very limited capacities. Having more access to this data in a legal and compliant manner would lead to more tools, well validated, that could be deployed, that could be trusted by clinicians, that would be useful for citizens and patients, and even for industry, that would be able to build solutions more rapidly, to validate them, to benchmark them. And this would also lead to additional growth for Europe. Another thing that I would like to emphasize is that fair doesn't mean open data. It doesn't mean the data is openly available. Quite the opposite. There are clear guidelines on how to make sure that the data privacy is addressed, that there are tools to make sure that the patient stays in control of the data, because at the end, the data belongs to the patient. So this is something very important within the fair data principle. Finally, to tell you that FAIR is emerging, in particular in the imaging domain. There was more works in other domains. There are several ongoing initiatives, like in You Can Share, but also Eurobioimaging. The European data infrastructure for imaging is investing a lot in this area. And in fact, if you remember the first use case that I described on liver cancer imaging, well, with the clinical partners that I mentioned, we submitted a proposal to the European Commission to build something similar to You Can Share, but in the cancer imaging domain. And this project, we were lucky, has been granted, and will start in October 2020. And it will have, again, all these different major data infrastructures like Eurobioimaging, the European Genome Archive. But we also invited the Cancer Imaging Archive from the US to be part of this project, because they have a lot of experience, and this will foster international cooperation. So this is the end of my talk. Just to give you some links, maybe if you want to find more information about You Can Share, but also by Eurobioimaging, who are playing a very important role. If you want to collaborate, if you want to be a user in the future of this platform, or test it, or collaborate in any other capacity, you're very welcome to contact us. And other than that, I would like to thank you for your attention, and be happy to answer your questions.
All right, thank you. Thank you very much, Karim, for this very, very interesting presentation. Very well structured, very clear. So yes, it's a very interesting initiative. At this moment, I can see one question. Oh, and there is a second coming in. The first is from Ignacio Blanquer, and he says, or he asks, can the user provide their own processing algorithms in the virtual research environment? And if yes, do you prevent users to download data, and how?
So can you repeat the question, please?
Yes, so the first part is, can the user provide their own processing algorithms in the virtual research environment?
Wrong processing algorithm.
Their own, yes, their own.
Ah, their own, sorry.
Yes.
Yeah, definitely. So this is a very important aspect. The platform will be scalable. Any person can arrive using a Docker container, add a tool, and then builds workflow with other tools that already exist. So this is really an important feature, because we want to give flexibility to the users. Otherwise, if we limit the user to very specific analysis tools, this will limit them severely. And also, we want to use this platform as a way for stakeholders such as company or researchers to validate their own tools. So for that, they should be able to indeed add their tools. So that was the first half of the question. The second half?
Yes. Can users download data, or are they prevented from doing that?
So it depends. It depends on the cohort. So there are different options. There will be cohorts who will sign for that option, which means if the user finds that cohort in the data catalog and then sends an access request and is given access to the cohort will send the data to the user. So there are examples. For example, the UK Biobank works like that. The UK Biobank prefers to send the data. There are other cohorts who have a different policy. They give you access to the data, but remotely, which means the platform will send the tools to where the data is located. So effectively, the user will have access to the data, but only remotely, will not be able to download the data. So that's another option.
Okay, thank you very much. I do have a question myself. How do the hospitals or the institutions providing the data, how do they have to prepare the data to make it usable in this platform?
This is a very important question indeed, because for the data to be searched, it needs to comply with a certain structure. So what we are going to do, so this is not yet in the platform, it's the cohort management part. So stakeholders like hospitals or researchers will be able to add data, and they will have a form, a set of forms that will have to fill in to provide this data, the way it's structured, etc. So we will give them a set of tools to facilitate this process. But the process is not fully automatic. This is not possible, simply. So there is indeed an effort to add a cohort to the platform. But we hope that stakeholders will see the value in that. So the first value is that they have a data set that now people are aware of, that gives them increased visibility, which means it can be used for research purposes, which will benefit society, patients, but it could be also a link to collaborate by adding that data set to the platform. They will be able to collaborate with different stakeholders. So there's a way to create networks and collaboration. So indeed, there is a cost of adding a cohort, but we hope there is benefits. And an additional one is that by adding a cohort, it will be possible to perform multi-center, multi-study research. So for example, I have a cohort, but it is not sufficient to build an AI solution. I add it to the YouCanShare platform, and now I can use it plus the other cohorts that are already part of YouCanShare. I place a data access request. They have access to the other cohorts, and now I combine the different cohorts, and now I can build an AI solution combining my cohorts and the other cohorts. So I hope that the data provider will see value in this over time.
Yeah, so the possibility to collaborate and for networking in research is one of the main incentives for hospitals to contribute and to provide their data.
Indeed, we hope that that would be one of the incentives, because a data set alone doesn't have enough heterogeneity, often doesn't have enough sample size. Mm-hmm. There is also maybe a lack of multidisciplinary expertise. Typically, a team will have good expertise in genomics, but not in imaging. So it is a data platform, but it's also a networking platform, we hope.
Yes. Meryl, maybe you can go for the next question. Well, in the meantime, I think I can go for the next question. There was one again, or two questions from Ricardo Corredor. He says,
oh, sorry, I was on mute, I think.
Oh, I'm sorry, no problem. You can continue if you want.
Yes, I was reading the question of Ricardo as well. So I will continue. Sorry that went wrong. So there have been other similar initiatives from the EU before and initiated by other groups such as VIP by Creatis or Midas from Kitware. Why do you think we are not using already those platforms? What has been missing until now? So in other words, what is different of the You Can Share platform compared to those other mentioned?
Yes, so I'm not totally familiar with this platform, so I cannot comment specifically. What I can say is that something that has changed in the last few years is the introduction of the fair guiding principle. And I think that has changed a lot of things. Now people are following a structure in the way they build this platform from the beginning. So they know they have to follow these guiding principles, and therefore there is no missing piece to the puzzle, I would say. We are aware of all the different challenges. We don't have all the solutions yet, but we are aware of them, and we are trying to develop solutions with other partners and with other projects. As I said previously, there are several other projects that are running in parallel. In fact, we are collaborating together. There are all sorts of working groups between these different projects. We are encountering all sorts of problems, so we share sometimes only the problem so we can plan ahead, and sometimes the solution if one of the projects have found a solution. But indeed, it's an effort that is required on a large scale, I would say. And previously, maybe we didn't have these principles set yet. So now we're in a much better position. I would add that now another important aspect is we have this big data infrastructure that have matured. So, for example, ELSI, the European Genome Phenome Archive, BBMRI, they exist during for a number of years, but now I think they have matured. They have accumulated experience, expertise, tools, and they're still developing. So if we talk about the data catalog, the BBMRI now has the data catalog, but it's still in developmental phase. Huh? So it's something that was not available a few years ago. And now we have this combination of expertise, of technologies, and awareness of these problems. And I think also of support, including from the European Commission, to develop this solution.
So, Karim, what I really like about this platform is the fact that you offer a complete solution, also integrating the way to run the algorithm, to run the networking, the neural networks. But is this something that makes your initiative kind of unique, or do you know other platforms that facilitate the let's say the democratization of developing or training algorithms?
No, I think there are other platforms that are doing this effort in very specific domains, though. The ones that I'm aware of, I mentioned in the slide previously, they either work in cancer genomics, for example, and they're doing all sorts of advanced bioinformatics and machine learning developments. So there are different solutions, different application. I would say a lot of them focus rather on bioinformatics, statistics, epidemiology, machine learning, not yet, not as much as in the other disciplines. So indeed, You Can Share is one of the few that have started doing that. But I would say that really the two things about You Can Share that are unique, the first one is that it has imaging. I think this is rare in the existing data platform. There are some, but not to this extent. And then the fact that we try to put everything together in a one-stop shop platform, yes, which improves the user experience. And I think that facilitates then the access to information, the access to the data, and then the analysis.
Yes, that's clear. Thank you. Merel, it's your turn.
Okay, I think there's one other question as well, but I think we can go to the next question of Ricardo in the meantime, and we will answer Anna Maria's question after this. Because he is asking if, this actually relates to another question I had myself. He says that in neuroimaging, there is a standard that takes a lot of attention for structured data. This standard is called BIDS. Are you considering to make this tool compatible with BIDS? And another question I had, whether, so this is for cardiac radiology, right? Are you also looking at other fields of radiology or to incorporate, I don't know, the thorax, for example? So this relates to this question.
Yes. So regarding, I will start quickly with the second question because the answer is you can image. So we were working on you can share, and then we decided to do something similar for cancer imaging, and we now have been granting this opportunity with this new grant that is called You Can Imaging. So CAN there stands for cancer. So indeed we will be doing that. And why we will be doing that, and at the same time answering the first question, we will be trying as much as possible to use standards. So for example, in the You Can Image project, we have the chair of the DICOM standards committee as part of the project. And there is there will be a work of making an inventory of existing standards and organizing consensus workshops, meetings, bringing different players from different domains, not only cancer, neurology as well, because in neuroimaging, in fact, it is true that a lot of advances were made in neuroimaging in the first place, and we need to acknowledge that and also thank the community for those efforts. So we will make this effort of looking into the different standards and using them as much as possible and even promote them, because this is very important. If we, the more we use this standard, the more interoperable will become these platforms. So it is in fact at the center of this platform development, but it's not easy because indeed there are different standards and there are disagreements. So this discussion needs to take place, and we need to reach some consensus on which standard we will use.
Regarding standardization, I also had a question, Karim. As far as understood, not all data are labeled, probably some are, but apparently I think that the labeling standardization might also be an issue for making these data usable or reusable. What do you think?
Yeah, I agree. Good question.
This is actually a very good question, and it sort of make me think of something we were discussing with my team very recently as part of this challenge that we organized, this multi-center, multi-scanner, multi-disease cardiac image segmentation challenge. And we had this issue indeed. We received annotations from different hospitals because we wanted to organize a multi-center challenge. This was the first one that was organized actually. And we realized that there was a problem, that these cardiovascular experts with 20 years of experience were labeling the cardiac images different. So we had to create another step where a single observer would go and make the necessary correction and standardization. And this was done manually. I don't have a solution for you like this. I have to just acknowledge that this is indeed an issue, and that will be addressed again through consensus, through discussions, through new standards. And it is therefore this sort of initiative are important by also creating these discussions. I hope they will exist. Whether we will reach consensus is another question. I have to admit that this is not easy, because when a cardiovascular imaging expert has been using a certain standard to annotate images for 20 years, it's difficult to change.
Yes. So, but yes, of course, that could be a very significant hurdle. That's habits. Maybe there are some other hurdles in the standardization of labeling. I don't know. Do you need standardization in software tools? Do you need more funding for research? Is there a lack of collaboration? So what do you think is the major hurdle for obtaining those standardizations?
Well, clearly, as we discussed, one of them is simply cultural and just the existence of many standards. I'm not sure how much the automatic tools will address this, because again, there will be many automatic tools. So if you have many automatic tools that are trained with different standards, they will be different as well. So I must admit that this is also something that is puzzling me. And this is something that for which we don't have an answer in UK and share, that's for sure. And we hope to collaborate with others that may have solutions. But certainly by starting to set up discussions, standards, and applying them, that would be the first step. And it has been shown in different areas that that this helps, in fact, in cancer imaging. So, for example, the ELSI, the ELSI group are working now on the standardization of radiomics. And how much they will be successful, I don't know, but there seems to be an interest, and I think this is the right direction.
Yeah. Meryl, I think there's a question from Ana Maria Marquez de Silva.
Yes, there's two questions still to go. First, we go to Ana Maria's question. She would like to ask how the quality of the data is assured and how this quality can be standardized or harmonized.
Yeah, this is also
briefly upon this already a little bit, but maybe you can elaborate a bit more.
Yeah, so very quickly, indeed, this is also an important issue. So in UK and Share, we have different tools that we will use to do quality control. One of them is called Square, which is developed in Germany, and it works relatively well with phenotypes. So with imaging, we decided to create our own using deep learning. So we will ask a number of experts, and they have already provided us with some data which have good quality and poor quality, and create just a classification deep learning based method. So we're trying to build some tools, and indeed this is an important question, and there are efforts to do this, but it is not straightforward. It requires some effort. It is part of the process, I would say, and it is part of the data analysis process. Once someone has access to the data, this data quality checking needs to be done, and I hope there will be tools for that.
Okay, thank you so much for your answer. We still have one last question, which I think is very interesting. Rodrigo Barros asks if we have all kinds of data from different centers and we apply a model or we apply an algorithm to these data, what will be, are there any domain adaptation approaches for dealing with the problem of domain shifts?
Yes, so this is definitely the case with image data. So there are differences, we know that. And it's part of the interoperability part of the talk. Indeed, there needs to be method developed to either select the phenotypes or indices that are robust, that do not vary significantly between scanners, for example, between protocols. And we've done such experiment. We found that indeed some of these indices are robust. Sorry. So, but the other approach indeed is well now established, and there have been a number of successes. It's still in progress. Is the use of methods like GANs to perform normalization. It is still challenging, but it is promising, I would say.
I have a question to finalize, to conclude, I think, Karim. So I can see in the first slides that you presented that there's institutions from different continents working together and willing to provide data. So both from Europe and the US. And of course, you undoubtedly know about the issues related to GDPR compliance, but on the other side, it's the HIPAA. But so what, if you want to upload data in this platform, what is the standard type of anonymization that you are using to make these data available?
Yeah, this is actually an important question. And this will be addressed hopefully in the You Can Image project that will start in October. There we will use for the cancer imaging data, we will use a tool that was developed and used for 10 years in the US. So we thought, because it's established, it's been used extensively, instead of developing a new one in Europe, let's use that one. But indeed, it's an American tool, and So our American partners think there is this GDPR compliance, but we will dedicate some time and resource to actually validate the tool and maybe adapt it, make some adaptation. So this will be a collaboration between the Cancer Imaging Archive and Bioimaging. So indeed, we are aware of this issue, and our American partners are aware of the GDPR. They're aware of its importance, and they are helpful, and they want their tools to be GDPR compliant. So I think we just need to dedicate some time and effort to that, and test the tools and make sure that they are compliant on both sides of the Atlantic.
Yes, of course, it's quite an important topic. So I would be interested in learning more about the tool that you are using for that purpose. But okay, I don't think there are any other questions. So I would like to thank everyone for having attended this meeting, and Karim, you too. Thank you very much again for having given this excellent presentation.
Thank you.
I would also like to thank our sponsor, which is Bracco, and of course, I want to repeat that the recording of this webinar will be available on the Usomi platform. And yes, of course, everybody is welcome to join our society and attend the next meeting and the next webinar. We have one every month. So please follow the announcements, and so that you will be able to attend the next webinar. So thanks again, everybody, and have a nice evening.
Thank you very much. Goodbye.
Thank you. Bye-bye.